Just going to go through the procedure for carrying out an insulation resistance test on a complete installation from the meter tails. First of all, of course, I need to use an insulation resistance tester. It's a Mega MFT 1730. It's a multi-function tester, does everything I need it to do and probably more besides. Need to make sure the leads are to GS38, very, very important. I need to check the instrument's not damaged at all. I need to check that it's working properly, so I would need to switch it on. My test voltage for this test is going to be 500 volts DC. Join the leads together and take a reading, and it tells me the leads are working. I also need to make sure the instrument is accurate. Some people say they need to make sure it's calibrated. That's not strictly true. It needs to be calibrated when you buy it, but of course you need to maintain a record of its accuracy throughout its life. So providing it's accurate, it's okay. This is my test instrument and I know it's accurate, so I'm quite happy to use this. First thing I need to do within an installation, of course, is take away anything at all that may be damaged by the test voltage. So I'm going to test at 500 volts. This is really a pressure test. I'm pressure testing the cables to make sure there's no leaks. I need to go around and remove all of the lamps, disconnect anything that's likely to give me any false readings. I also need to bypass any dimmer switches, motion sensors, stuff like that, which obviously is an electronic switch. I need to disconnect any fluorescents. I need to make sure that all the light switches are switched on. If I don't know the building, if I've any doubt at all that there's going to be something in there may be something in there that may be damaged by this voltage, I would do the test first at 250 volts. If I do it at 250, if I get a bad reading at 250, there would be no point in proceeding to 500 until I found out what was giving me a poor reading. So at 250, it may be okay. When I get to 500, I may get another bad reading. That would indicate to me that somewhere within that building there would be surge protection, which is going to break down at something over 250 volts. So it's just a process of elimination, really. Once I've carried out all of that, I need to make sure that all of these switches are turned on, okay? I know the instrument's working, and I need to test, first of all, between live conductors. Push the button, and I've got a reading of 0.03 between live conductors. That's telling me that that's a low resistance fault, okay? But, okay, I know there's a fault between live conductors, but there's no reason why I shouldn't carry on and do the rest of the insulation resistance test first before I start looking to see where the fault may lay. So, line to earth now. Greater than 999, so I know that's okay. Neutral to earth now. Again, greater than 999. So I know that my fault lies between line and neutral, okay? Just double check. Definitely a fault there. So to find the circuit on this board, it really is a simple process. I just turn off the circuit breakers one at a time. I've no idea which one it is, but I'll just keep turning them off until I get a good reading. Turn on those two again, and now I can see that my circuit is in fact number 4. I've got a fault on the immersion heater. At that point, because it's between line and neutral, I may want to look up in the airing cupboard just to make sure that the immersion heater is not switched on, or possibly there's a neon indicated lamp on the switch. So that would be the first place I would look.